Hi, it has been an honor to speak here and to speak after you guys. It's great to listen to your stories. I will start with 3 questions. First question, how will the future energy sources be maintainable? The second question, how will our journeys to Mars become viable? Third question, how will we solve our future nuclear challenges? A part of the answers lies in our great team of MAGIX, and co-founder Ying Zhao, the smartest guy I ever met. And everything we do will not be possible with this incredible team. And it is also made possible by going boldly where no electronics has gone before. What does this mean? This means that we go into environments where it used to be not possible to place electronics. That we go literally where no electronics has gone before, and I will tell you more about this in our last slides. First question, another question. Why electronics? Electronics is part of our daily lives, but always invisible, and it's a pity, because sometimes we do not understand the true value of electronics. But electronics, thanks to electronics, we can drink our coffee in the morning. We wake up by our smartphones or a clock radio. Or in my case, with my little kids. I have three little kids, and I don't need a smartphone to wake myself up. They're smart enough to wake me up. So, with MAGIX, we make electronics. And we differentiate on 4 different levels. We make the difference in the world on 4 different levels. On integration, intelligence, radiation hardening. I couldn't find a word that started with an I. Innovation, the other word. And listen carefully to these words, because it was my birthday yesterday, and you will get a free consumption for every time I say these words. They will be the red wire through my presentation. First keyword, integration. Integration is a central element in every competitive world. It enables operation at greater speed, lower cost, higher quality, and higher complexity. It is critical as an enabler for growth, competitiveness, and job creation. But what does this mean in our world? In our world, this means integrated circuits. Lots of electronic functions integrated into an integrated circuit. What happens with this integrated circuit? This integrated circuit is again integrated into our chips. And these chips are then mounted on these green boards you probably know from your computers and used in all kinds of applications. So, the second keyword, intelligence. Intelligence. So, everything that we have, that we know, our smartphones, they contain chips. They become smart. In the same way, we make environment smart by electronics. We make robotics smart by electronics. Electronics, they are the nerves and the brains of our environment. Unfortunately, electronics fail when you place them in a radiation environment. And that's where our third keyword is coming from, radiation hardening. Now, why do regular electronics fail? They fail due to 2 reasons, 2 main reasons. There are many reasons, but 2 main reasons. Total ionizing dose effects and single event effects. So, these total ionizing dose effects, they're caused by ionizing radiation, gamma radiation. And they can be explained by this funny character. I got the inspiration from my son Jeff. So when ionizing radiation hits electronics, electron-hole pairs are created. Now, these electron-hole pairs, they are absorbed by the sponge, by the electronics, sorry, just like water is absorbed in the sponge. And there can be so much radiation being absorbed until the electronics has enough, until the sponge loses its functionality. It cannot take any water anymore. And at that moment, electronics start to fail as well. The second effect is called single event effects. These are effects that mainly happen when you place electronics in space environments. So and the example you see here is a solar flare. These solar flares, they create a whole bunch of high energetic particles. And let's again take the example of the sponge. But now the sponge is already fully loaded with water. And what does a high energetic particle do? When it hits the electronics, the transistors in these electronics, they lose charge. Just like a sponge, when you squeeze it, the water drops. In electronics, this also means a memory cell, for example, that goes from 1 to 0. Now, what are radiation-hardened electronics? If I would like to keep it very simple, our electronics. But what we do with our chips, what we do is we do techniques that are called radiation hardening by design. This means that we do tricks on system level, schematic level, and layout level, on 3 levels. And I like to use this Lego picture because actually transistors can be compared with Lego blocks. They are a small block, and you can make all kinds of structures, all kinds of amplifiers in our case. Now, normal electronics can be compared with a normal Lego house. But we build solid structures with our Lego, with our transistors. Solid structures that survive the effects of radiation. And then for the single event effect, we use techniques which are called triple mode redundancy. This means that we triplicate our digital designs, you can say. But this goes already much too far, maybe. Then, third keyword, innovation. We are continuously pushing our limits. I really like the presentation of Petra because we're also busy with some new big science projects like the ITER reactor, for example. And there also they need to push the limits of technology. And it allows us to make things better in our world. And that's why we always go boldly. I really like the slogan, also because I'm a fan of Star Trek, but let's talk about it. So, how do we maintain these new energy sources? This can be an SMR. SMRs needs to run autonomously to be cost efficient. But also this example that you see here, the ITER reactor. It's a fusion reactor they are developing in France. And they are recreating the environment of the sun in this reactor. Now there's a lot of maintainability required on this machine, a lot of remote handling tools required, and we have developed a complete set of chips to control the remote handling equipment in this reactor so that it can be maintained. That is what we have done for this reactor. And also sensor networks that can retrieve information from this reactor. Another application where we are now more and more getting involved in is space. And it's so fun when you need to do a presentation on Tuesday and then you read the newspaper. In this case, it was the TED. And I couldn't resist to use this quote. A quote from Chris Lewicki, CEO of Planetary Resources. Planetary Resources is an asteroid mining company. You think this is science fiction, but this is really becoming reality. We're talking about five years here, and the technology for these applications are being developed. And he's quoting that before you know it, you have a whole economy in space. There is a new industry coming in space. And we are becoming part of that. We make sensor networks that can survive in these environments and that measure the environment of such a village, for example. Or we make the electronics that make the remotely operated vehicles on space possible. Another one, social challenges. We are going towards a nuclear phase-out, and we are facing some social challenges. We cannot ignore that. How is this waste going to be maintained in an intelligent way? How can we follow up how these concrete structures are evolving, or if these barrels are getting corroded or not? We can do this with intelligent, integrated circuits. That's how we can do that. So this leads me to the innovations we are bringing. So the first innovation that we bring with our intelligent, integrated circuits is we embed them in smart sensor networks. Smart sensor networks that can maintain the houses on the moon or operate those rovers, or smart sensor networks that can follow up our legacy waste. Another field where we are active in is smart robotics. Here, our integrated circuits are embedded into networks that make these robots more intelligent. It allows them to become more autonomous. It allows them to become more cost-efficient. People can reduce cost by making these robots more smarter. It's a huge issue in decommissioning, which is a very cost-driven industry. Now, let's go to the end of this presentation. I see that my time is up. But I'm not the only one who spoke over the time, so I think I get an exception. So smart sensor networks. What we are doing is we make smart sensor networks. You continuously hear about the Internet of Things, about machine learning. Now, smart sensor networks. 50 billion devices will be connected by 2020. This means huge bandwidth requirements. And now here comes the problem. So the current throughput of a network, of a Wi-Fi network, is limited. Also, the battery power of these wireless nodes is limited. So what do we need to do? We have too much information that is coming from our sensors. Our batteries, they cannot stay on too long because they continually need to transmit information. What do we need to do? We need to reinvent the physical layer, and this is actually the next bold step we are taking, a next innovation we are bringing, the next step we are pushing ourselves for. This is basically what you see here is machine learning. Machine learning nowadays is done in the cloud. And in this cloud, there's a lot of information. But what we are doing now, we are bringing this machine learning towards the chip. We are bringing it to the edge, so that instead of the need to send raw sensor data, you send, for example, if you take the example of corrosion, you only send information when a corrosion event is happening. You only send information when something is changing with concrete. You only send information from the sensor when a motor is running out of oil. You only send information, for example, when a motor is heating up. And this can be really a big breakthrough in the Industry 4.0. It can connect trillions of devices with the existing networks. And we are currently making this. This is really exciting. And also, sensors, they help. Our electronics helps us not to fear our environments, but to understand our environments by getting data. And that is also where our quote is coming from. Nothing is to be feared, only understood. And we always go boldly. And you can beam me up. I couldn't resist to make this joke. You can beam me up at that phone number. So many thanks for your attention. And